This video is going to go over the most missed questions from Unit 4 test. The very first one I want to go over is going to be solving by using Cramer's rule. We have a system of equations, so one of the first things we're going to do is find D. D is the determinant of our coefficient matrix, which is 2, 3, 3, and negative 2. We're going to go find the determinant of that. Remember, the way to do that is we are going to multiply these two and get negative 4. And then we're going to multiply these two and get 9, and we're going to subtract those, and we're going to find that to be negative 13. So the next thing we're going to do is we're going to get our dx, which that means is that we're going to get our answers, which is 18 and 24, and 18 and 4. And we're going to replace these x coefficients with 18 and 14, but the y coefficient stays the same. And we're going to take the determinant of that. When we do that, I'm going to get negative 36 minus, and then I'm multiplying these two, and I'm going to get 12 carrier 1, 42. And we're going to see that that's going to be a negative 78. And then last but not least, we're going to get our determinant of y, or dy. So we're going to get that answer one, and we're going to change these y values to 18 and 14. And we're going to keep the original x coefficients, which are 2 and 3. We're going to take the determinant of these, so I'm going to get 28. That's multiplying these two. Minus, and then I need to multiply these two. I'm going to get 24 carrier 2, which is 54. And then I'm going to subtract. We can see I'm going to get a negative number. Let's see, 26. A negative 26. Alright, so in order to find our x and our y, what we do is we get our dx, and we divide it by our determinant of our coefficient matrix. So in our case, we're going to do negative 78 divided by negative 13. We're going to see we're going to get a positive answer. So that's going to be a 6. And then we do the same thing for our dy. Divide that by d. That's going to be negative 26 divided by a negative 13. And we can see that that's a positive 2. That means our solution set is the point 6, 2. And we can always check by going back into our original equation and make sure it works for both equations. The next problem I'm going to review is actually going to be solving this inequality system. I think the vast majority of us were pretty good about drawing this line, but I'm going to go over that really quick. If I let x equal to 0 for this line, then I'm going to get 6y is equal to 60, so y must equal to 10. And if I let y equal to 0, I'm going to get 10x is equal to 60, so x must equal to 6. So we can see that we're going to have a line, a solid line, because that is an equal to, from 0, 10, all the way to 6, 0. So pardon my non-straight edge line. So that's what we have here. And we can do our test point of 0, 0. And if I plug in 0, 0 does indeed equal to less than 60. So that means we're going to shade in this direction. I'm going to pick up a different color, and let's talk about the equation of y is equal to x minus 3 squared. So I think a big problem that we had with this one is to remember what does it mean when we have x minus 3 in terms of our transformations. This will transform our parabola 3 units to the right. So what happens is that we can also plug in points. You know something funny is happening when x is equal to 3. And when we do that, when I plug in x is equal to 3, 3 minus 3 is 0, y is equal to 0. So that kind of gives us a clue. And if we let x equal to 4, we're going to see 4 minus 3 is 1, square that is 1. And we can keep doing that, so I'm going to do one more. At 5 minus 3 is 2, 2 squared is 4. So what we're seeing here is at 3, 0, I have a point. At 4, 1. And then if I go over 2 to the 5, I go up 1, 2, 3, 4. So we should see that our parabola is doing this. And it actually has an axis of symmetry, so it's doing the same thing on this other side. And because it is less than and not an equal to, we actually need to make that to be dashed. So I'm going to go in here with my little eraser and cause it to be dashed. Alright, so now we're ready to test our points. So remember, we're testing into the original equation. I can test my origin, which is right here. So when I plug in x is equal to 0, I get -3, then I square it. That's going to give me a +9. And the question is 0 greater than 9? And the answer is no. We're going to actually shade the location where our origin is not located. So we can see that it's going to be inside here. And we can also see that this is bounded because technically I can create a circle and bound it within that circle. So that's how you can tell if something is bounded or not. For the next test, you're not guaranteed to have a parabola, but I just wanted to remind you that if you have y is equal to x squared -3 like this, or +3 out here, that shifts it up or down. And if you have it on the inside of the parentheses, then it's going to shift it left and right. So again, it just depends on what that sign is. Same thing here. If we have a negative on the front of our x squared, remember that that's going to cause it to open down. So again, like I said, you're not guaranteed to have a parabola, but I did want to make sure that I covered solving parabolas that have been transformed. And then the next question we can ask, I think that was the one other misconception we had on my question, my fault, and that was, is the origin in the solution that we see there? And we can see that here's our origin, and it's not in that yellow shaded area. So the answer is no, the origin is not in our solution set. And that concludes this video.